Okay, 4 passed. Let me go through this. All right, I'm turning my video off so that I can move my screen and write on it. Otherwise, you'd be staring at my ceiling, but I'm just on the other side. So don't feel scared to ask questions. Oh, wait, before I turn that off, just remember that this class gets quite big. So if you would like to say something or ask a question, if you could just use the hands up emoji when you need to ask something, and then we'll call on you and you can ask your question or give an answer. And then if you have questions while I'm speaking, just jot them down in the comments. And as soon as I see them in the comments, I will respond verbally. So you don't need to panic about unmuting to ask a question. If you've written your question in the comments, I promise I will see it and I will answer. Okay, and if it feels like it would be too much for me to answer while I'm still teaching, I will send you to Mr. Shongwe, who is also a brilliant math teacher and will be able to help whatever your concerns are. Okay, let's get going. So just remember to all keep yourselves on mute until you have a question, and then just use the little hands up thing. Okay, so in a question like this, the easiest thing for us to do is substitution. And when we're doing substitution, we're wanting to isolate a variable. And in this one, remember, we're looking for a lonely variable. So the easiest one to isolate would be that x. That is our loneliest of variables in both of our equations. Okay, so the first step we're going to do is we are going to isolate a variable, and we can either isolate x or y depending on what our equations look like. In this case, we are going to isolate x. So we're going to say x is equal to 4, and this 3y is going to jump over to the other side. So it is going to become plus 3y on the other side. Okay, that's our first goal. Now we know that this whole situation over here is what x is. And that is also an x. And so instead of writing x, we are now going to write what we have just figured out x to be in terms of y. So we're going to say 5. And now instead of x, we're going to write 4 plus 3y, because that is what x is, minus 2y equals 7. Now, at this point, I'm just going to say, if this is your first time seeing simultaneous equations, if you weren't in the lessons last week, please don't panic. This is really just for the people who were here on Thursday to go over what we did. And we will be doing other work as we move through the lesson, so please don't stress. Okay, so that's our next step. We have made this 5x minus 2y, but we've substituted in the isolated value for x. Now we're going to distribute that 5. So we're going to get 20 plus 15y minus 2y equals 7. I'm going to keep my variables on one side, and I'm going to move my numbers onto the other side. 15y minus 2y gives me 13y. 7 minus 20 is negative 13, which means that y is equal to negative 1. So quite a few people got to that answer, which is great. Then to find x, we just need to take it back to this stage over here, and we need to just substitute it into that equation. So x is equal to 4 plus 3y, but we know that y is equal to negative 1. So x is equal to 4 plus 3 times negative 1, which is 4 minus 3, which means x is equal to 1. And so y is equal to negative 1 and x is equal to 1. How did this question go? Tell me how you feel. Feeling good, feeling terrible, feeling great, feeling somewhere in between. How did this one go? Great. Mr. Shongwe, can you help? I think we have an audio situation with Makwena. Let's see. Good. Look at all these happy emotions. That's excellent. Great. And now while you're on this wonderful mathematical high, I'm going to just take you straight into the exponential land. So we're going to go straight from here into exponents. It's going to be great. It's going to be lovely because we're going to learn to love exponents. Okay. Before we jump into it, who has done exponential equations in class already. So when I say an exponential equation, I mean something like this. So a very, very easy one would be something like that, for example, where you're looking for an x, but it's an exponent. So who has done that in class? You can either use the hands up emoji or you can let me know in the chat. Started today, not yet. Okay. Lots of people have done them. That's great. Great, Canva. That's okay, Maria. That's why we're here.
Also done it.
Good. Oh, sorry. I think I might have unmuted someone by mistake there. Sorry about that. Okay. Sometimes teachers do that because it helps you in the long run. So like if you can sort of figure things out by yourself, that's why what he's meaning by he wants you to struggle. If you can figure things out by yourself, then it helps you in the long run. So I think that's his strategy. Okay, let's have a look. I'm just going to lower these hands because you were just answering this question, just so I don't think you can ask another question just now. Let's dive right into exponential equations. So we're going to start with some nice, easy ones just to sort of slowly get into what exponential equations are. And we're going to talk about all of the different steps to get to where we need to go. And then hopefully by the end of the lesson, we can try some trickier ones. Okay. Okay. So some Kelo. Oh, I think that's another audio issue. Mr. Strongway, can you help some Kelo for me?
Yes, I'm onto it.
Oh, thank you. Okay, so when we are dealing with an exponential equation, our first goal, before I even jump into this, can everyone please make sure they have their calculators with them? These calculators. I know mine looks different, but like this. Please, can everyone grab their calculators? Your calculators are your best friend when it comes to exponential equations. So I'm going to show you steps when we're dealing with these really easy ones. I'm going to show you on your calculator how it can help you. And then when we get to the tougher ones, you're going to be like, oh my gosh, I love this calculator. Oh, you have the white one as well. The white one does all kinds of glorious, fun things. It factorizes all your trinomials for you in this magic little white box. It does. So you don't have to do the crisscross or grouping. It does it for you. It's very sneaky. Okay, let's have a look. So I know this is a super easy question, but I want you to sort of learn some steps in your calculator. So what I want you to do in your calculators is I want you to put in the number 8. So we're going to, I know that this is ridiculous. I know you all know that it's 2 cubed, but just for the sake of it, I want you to put in the number 8 into your calculator. Okay, so I've just put in 8. And then I want you to push equals. So far, what I've put into my calculator is I put in this is going to be messy. I've put in the number 8 and I've pushed equals. Okay, so it just looks like this. Then you're going to push shift. So you're just going to tap the shift key. So you're going to shift. And then you're going to look for the button on your different calculators, maybe in different places, but where you've got, it's like a circle and then 3 commas. It kind of those look like G's, but you know what I mean. And then above it in yellow, it says fact. You want to find the button that looks like that. Okay. And you want to push it. And you'll see that it gives you the answer of 2 cubed. Okay, did you learn that last week at school? That's great. Okay, so if we can do this, if we can do shift fact, it always is going to get us to where we're wanting to be. Basically, what shift fact does is it gets our numbers to their prime bases. And that's what we want in exponential equations. We want everything to be in its prime base. Okay, so for anyone who hasn't done this in class yet and is feeling a little bit lost, these are just your steps. You're going to, thank you, Mr. Strongway, he's written it in the chat for us. You're going to write whatever your number is. You're going to push equals, you're going to push shift, and then you're going to push fact. And, oh, sorry, let me turn my video off before I turn the screen. And you are, what this is doing is it's getting things into their prime basis. Okay, so our whole goal when we have an exponential equation is we want the bases to be the same. Because if our bases are the same, then our exponents are the same. That's our goal. Okay, so in this case, my base is 2, which means I want my base here to be 2. So I've got 2 to the power of x is equal to 2 to the power of 3. That's our first step, okay? And once we're there, because our bases are now the same, and I know that this is feeling like I'm doing an overkill of a question, which is nice and easy, but remember in maths, you can't do the tough ones if you don't understand the processes in the easy ones. Once our bases are the same, our exponents are the same, which means we can then say, therefore, x is equal to 3. Okay, so let's just kind of go through this so that as we get to the tougher ones, you know what you're doing. When we have an exponential equation, our first goal is we want our bases to be the same. And in order to get our bases to be the same, we use this lovely little trick of using shift fact in our calculator to get it to its prime basis. Okay. I just want to make sure that everyone is understanding how to do shift facts. So can you please get 4096 into an exponential form? So I want it to have a base and I want it to have an exponent. Please, can you tell me what 4096 is using shift fact on your calculator?
It's 2 to the power of 12.
Yes, excellent. It is definitely 2 to the power of 12. Good, 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 good. Okay. So I never want you to be sitting in a test with your calculator going 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. We use shift fact and we get there nice and quickly. Good. Excellent. Okay. Let's try another one. Now for this one, I want you to think carefully about what that fraction means. I want you to give it a try, and then we're going to kind of talk through it step by step as you go through it afterwards. So everyone give this one a try,
Ma'am,
and then we'll talk through it. Anele, how can I help?
isn't it 3 negative cubed?
3 negative 2.
Cubed.
Oh, yes, so it's x is definitely going to be negative 3, but you're going to need to write all of your steps in there to get to that final answer. Remember, maths teachers love seeing your steps, and steps are also there to help you, because if you make a mistake, then they're able to do continued accuracy marks. So I'm seeing some good things happening in the chat here. The first thing that we're wanting to do, because we don't want to skip any steps, is we want to say that that's equal to 3 cubed. So 1 over 3 cubed. That's our first step. Okay. So the first step is we get this 27 into its prime base. But I can't compare these right now because the one is a whole number, the other one is a fraction. So I have to move this dude up to the top. And when things move, their exponents change. So if they were positive, they become negative. And if they were negative, they become positive. Exactly, Lee Kaylin, exactly. So when this moves, it's going to... Hello? When it moves, it's going to become a negative. So that's going to become 3 to the negative 3. So when an exponent is at the bottom and it moves up, it becomes negative, or if it moves down, it would also change signs. And now, because my bases are the same, my exponents are the same. So now I can say, therefore, x is equal to negative 3. Okay. So this is like a really important concept, is to understand that when things move up, their signs become negative. Okay, let's try. What can we try with this one? I'm trying to think of what would make this a little bit tougher. Let's try this. Okay, so I want you to try 4 to the 2x is equal to 1 over 8. I want you to think about what we've just done. This is obviously a little bit tougher, but I want you to follow the same steps. So this first step, I want you to replicate it. I want you to get everything into prime bases. So with prime bases, you're also going to have to change this guy. Those are the two you're going to have to think about your prime bases. Then I want you to think about moving it up so it would become a negative, and then I want you to think about what your answer would be. Okay. And if you wanted to do an extra step here, you can. And if at any point someone's feeling stressed or confused, just let me know. Just be like, oh, I have no idea what's going on, or I just don't know where this number came from. I don't know what happened in that step. Just let me know. And if you feel embarrassed to write it in the full chat, you can send a direct message to me and I can help you from there. So Kayla, how can I help? I see your hands up. If you're talking, you're going to need to unmute.
I'm lost.
No, that's okay. That's okay. So your first step is you just wanting to get things into their prime bases. That's your first goal. So just get everything into prime bases. Don't worry, I promise I will explain the whole question. I won't just leave you guys without an explanation. I just want you to try first. Okay. Okay. So my first question to you is, how can I write 4 as a number with an exponent? So how can I write 4, just this number over here, how can I write 4 as a number with an exponent? Who can tell me what that would become? Just the 4. I don't care about anything else.
2 squared.
Yes, exactly, Kamba, 2 squared. Okay, exactly. So everyone should feel comfortable with that so far. So 4 is going to become 2 squared. Okay, so all I've done here is I've changed that 4 into a base and a power. Okay. Now on the right-hand side, I need to do the same thing to this 8. So what is 8 going to become?
2 cubed.
Exactly, 2 cubed. Beautiful. Okay, cool. Cool. So that takes us to the step over here. Now, we're already on the right track because we've got 2's on the left and we've got 2's on the right. So we know we're doing something good. When I have a power that goes to another power, what do I do to those exponents? So what happens when I have a power to a power?
You multiply them out.
I multiply. Yes, guys, exactly. I multiply. So that's going to become 2 to the power of 4x. And that's going to be equal to, now we want to move this guy up to the top. And then when it moves to the top, it's going to become negative. So we have 2 to the negative 3. Okay. Now at this point, my bases are both 2. So my bases are the same. And when we get to the point where our bases are the same, then we can say our exponents are the same. So now we can say 4x is equal to negative 3. And I want to know what x is. So I'm going to divide both sides by 4. And I'm going to see that x is equal to negative 3 over 4. And that's going to be my final answer. Okay, does anyone have any questions about this? Georgia, how can I help?
Hi, Mom. So, how did you get the 4?
The 4. This. Hold on. Let me just get it.
Mom.
Yeah. Okay. This dude over here. So when I changed this 4 into its prime base of 2 squared, this square is then multiplied with that 2x over there, because when I have a power to a power, we multiply them. And so that's 2 times 2x, which gave me 4x.
No, ma'am, like
Yeah.
the one like below that.
This
Like-
4.
Yes, ma'am.
Okay, that 4 is just looking at these exponents. That's just looking at this guy, that 4x, and that -3. So when our bases are the same, then our exponents are those two exponents. So 4x is equal to the -3.
Thank you.
No problem. Lebo Gang, how can I help? Gang.
How did you get -3?
So the
That's
-3 came because I had this 2 to the power of 3, but it was at the bottom of my fraction. And when we move it to the top of our fraction, then that power becomes a negative. So that's the same thing as what happened on this left-hand side. When I have a power at the bottom, so I have 3 cubed here at the bottom, when it moves up to the top, it changes to a negative. So it's one of our old exponent laws is if I have 1 over x, that's equal to x to the -1. If I have 1 over x squared, that's equal to x to the -2. So if it's at the bottom and it moves up to the top, it becomes negative.
Thank you.
Okay. Nokobonga, I'm all yours.
Ma'am, can I please ask? So, even if the answer is a fraction, can we simplify it to a decimal, or should we leave it like that?
Every single time you have an equation, leave your answer as a fraction.
Okay, ma'am. Thank you.
Sure. Kazimla, how can I help?
Ma'am, I got the same answer, but
You got the same answer, but sorry, I lost the end of your sentence.
I used I used a different method.
That's okay. That's fine. It doesn't have to look exactly like mine. If you're feeling comfortable with what you're doing, that's absolutely fine.
Oh, because mine is shorter than yours, but I still
Yeah. Taking out every single step and all of them in between. It's totally okay if it's shorter. Okay, let's try another one sort of similar to these, and then we'll try a different type of question. So let's do 7 to the 3x is equal to that's a little bit yucky. Nice big number, 117,649. Okay, so 7 to the power of 3x is equal to 117,649. Let's see how that goes. I know it's a big number, but remember that's why we have our calculators. We literally just put the number in, push shift fact, get our prime base, and we're sorted. Mulanga, how can I help?
Miss, I don't understand how to put a shift in my calculator. My calculator doesn't have a shift, so I was wondering if there's any other method I could do to calculate this.
So Mulanga, what I'm going to do is I'm going to ask Mr. Shongwe if he can send you a direct message so that you guys can try and figure out what will work best with your calculator. Okay, so he's going to send you a message in the chat.
Okay, thank you.
Okay. Okay, so in our calculator, if we do shift fact with 117,649, we get 7 to the power of 6. Okay, so first step, we get things to the same bases. 7 to the power of 3x is equal to, oh, guys, I made this too easy. I put it at the top instead of 1 over. Oh, anyway, okay. 7 to the power of 6. So all we're doing is we're putting this into our calculator. We're using shift fact, like we did right at the beginning of the lesson, to get it to its prime base. And we get 7 to the power of 3x is equal to 7 to the power of 6. Okay. Once our bases are the same, then our exponents are the same. So then we can say 3x is equal to 6. And then we can solve for x. So we can divide both sides by 3. And we can say x is equal to 2. Nokobonga, where are you feeling lost with this one?
No, I got the answer.
Okay. Okay, good. Okay. Let's try one more where we look at a fraction, because I was a little bit of a dumbass and forgot to make this one a fraction. That's all my fault. So but you know what? All practice is good practice. So let's do 5 to the power of, what should we do now? Let's make this 4x is equal to 1 over 3,125. Diane, if you can't see anything on the screen, the easiest thing to do is to leave the call and come back on, and then it should pop up when you join. Lebogang, do you have another question?
The 3x and over 3 cancel 3.
Yes, so I put that 3 there so that I could get rid of the 3, and then I divide it on the other side. So I just get to the x is equal to 2. No problem. Okay, so give this one a try, guys. Try
ma'am.
follow your steps. Yeah, hi.
I think x is equal to -5 over 4.
I will let you know shortly. A fraction is not necessarily a wrong answer. I'm seeing some good answers, and then I'm seeing some people who are making mistakes with signs. Remember, if it's a fraction and it's moving up, it's going to change sign. Oh, Wami, I haven't heard from you all lesson. How can I help?
Ma'am, is my answer supposed to be a fraction?
Yes, your answer is definitely supposed to be a fraction. So maybe it's right.
Thank you.
Maybe we should trust it. Okay, let's see. Okay, so first thing we're going to do is we are going to get things to their prime bases. So I've got 5 to the power of 4x over here, and that's equal to 1 over 5 to the power of 5 at the bottom. And we've used our calculator to get there. We're going to move that up to the top, and when it moves up to the top, it's going to become negative. So 5 to the power of 4x is equal to 5 to the power of -5. Now that my bases are the same, when I say bases are the same, I mean they are both 5s. I can say that my exponents are the same. So 4x is equal to -5, and I want to know what x is, which means x is -5 over 4. So a big congrats to everyone who got that right. That is awesome. Nice job. Okay, I feel like we've done quite a few of these fraction ones, so we're going to move on to, we're still in exponents, don't worry. We're just going to move into slightly different ones. Nasipo, how can I help?
Nasipo, you can unmute.
Oh, I want to ask about how did we get 4x over 4?
So the over 4, we're just putting this, we're dividing it by its coefficient. So when we have 4x, we're wanting to get rid of that 4. And so we're just dividing it by 4 so that it goes away. And what we do to one side, we have to do to the other side. So we're just dividing both sides by 4 so that my x can be alone. Okay. Okay, let's move into, no problem. Let's move into a slightly different one, but I think after the other ones, this one's going to feel a little bit easier because we're not dealing with a fraction anymore, but just give it your best go. Mulanga, did you land up getting help with your calculator? Is it all sorted?
No, I didn't get the shift still, and my mom says this calculator is a scientific calculator.
Mr. Shongwe, were you able to help with that?
Yeah, Mulangi, did you check your chats?
Yeah, I
Check-
did.
Okay, check the chat, Malanga. Mr. Shongwe will be in touch with you there, okay? So look for messages that say direct message from him, and then you guys can chat on there. So you can answer to him as well and just ask for help. All right, let's see how we go with this and tell me what I get for my answer. And then hopefully we're going to be feeling a little bit more confident after this. I can tell you that your answer is going to be a fraction. But in Corsi, I think that you may have made mistakes with some of your signs there. I think you may have plus something instead of minus something. You're welcome. Seko, I think you may have forgotten that you're dividing by a negative coefficient, and mutlaq are the same. Cool. Yeah, there we go. Okay, let's chat. First step, we want to get the same bases. That's our goal. We want to get the same bases. Okay, so 10 to the power of negative 2x plus 3 is equal to 10 to the power of 2. And if we didn't know that 100 was 10 to the power of 2, we can use our calculator. As soon as our bases are the same, we can say that our exponents are the same. So now we can say negative 2x plus 3 is equal to 2. And that came from saying this exponent is equal to that exponent. Okay, now it's just a normal equation to solve for x. So I want to move my 3 over. So I'm going to say negative 2x is equal to 2 minus 3 because of the sign changes. Negative 2x is equal to negative 1. And now I'm dividing by negative 2 and I'm dividing by negative 2. Those are going to cancel, and a negative is going to become a positive. And so my answer is going to be positive half. Sorry, Seko, I thought you had written, and Mutlaq, I thought you'd both written negative a half, but you had written positive a half, which was good. Okay, let's start with these questions. Kazimla, how can I help?
Ma'am, when I put in 100 on my calculator and then I put a prime base,
Yeah.
it gave me 2 squared times 5 squared.
Did you just put in 100?
Yes, ma'am.
Okay. Hold on, let me just, oh yes, you know, it could do that because of 5 squared is also a prime base. Yeah, no, that's okay. So sometimes it will do that.
I just,
yeah.
When I got that, I just took 2 squared times 5 squared. I added the exponents, and then I got 4. And then I continued with it.
Yeah, so if you get to this point over here, if these exponents are the same, you can multiply those two numbers. So you can say 2 times 5 is equal to 10 squared. But most of the time, so this was a nasty question on my part. Most of the time when you're given a question like this, if it's not just like a normal square, so here like we know it needs to be 10. So if we get an answer like that, then we can think, okay, well, it must be 10 to the power of something. So we can sort of figure it out from there. But most of the time when you're given these questions, they'll give you ones where the calculator is going to give you a nice answer because they do try and help you. Okay. why isn't 10 in the second prime base in its prime? So the thing is with prime bases, this is the only nasty thing with prime bases, is that 2 and 5 are both prime numbers. So this is giving it to you in prime bases. 10 is not a prime number, and that's why it's not a prime base. So sometimes we have to do a little rearranging ourselves, if that helps. Okay, so first goal is we just want to get things to the same bases. Second goal, we want to make our exponents the same as each other. And then last goal, we want to solve for x. Emmanuel, you're welcome to ask a question.
Good evening, ma'am. Ma'am, I wanted to know why did the number change from -1 and over -2 to a +1 over 2?
Okay, so when we divided here, we said we had a negative number and we divided by a negative, and a negative divided by a negative is a positive.
Oh, okay. Thank you, ma'am.
No problem. Okay, guys, I think we're just going to take a quick brain break. Just shouldn't take you too long, although it did seem to confuse some of the grade 9s. Quick brain break. So for those of you who are new, who are like, what on earth is this? It's just a little chance to give your brain something different to think about, and then we'll jump straight back into exponents. Okay, so I'm wanting to know what my final answer is there at the bottom. If you have your answer, write it in the chat for me, and I will tell you if you are right or wrong. No answers yet. Not 16. Not 12. Not 4. No, not 3. Not 6. Not 96. 56. There we go. See, Mom Kelly got it right. That's awesome. Let's see if anyone else can figure it out. The answer is definitely 56. Nice. Okay, those of you who are trying to figure it out now, I don't want a number anymore because you know the answer is going to be 56. I want a word, just one word, that would be a hint as to how you know it's 56. So think about one word you could write.
Ma'am, it's the eyelashes.
Well done.
It's
There
the
you go.
eyelashes, guys. It's the eyelashes. Have a look. So the colors meant nothing. It was 3 plus 3 plus 3, which was 9. And then it was 6 times 3, which is 18, minus 6, which is 12. And this one was 8 plus 8 times 6, which was 56. But let me just erase my answers for you. And then if you want to, you can take a quick screenshot and you can show your parents and see if they can solve it, or you can try and make some bets with your friends, see if you can get a free chocolate out of them. Give them like 30 seconds to figure out the answer. And if they don't figure it out, they have to give you chocolate. Okay. All right, let's jump straight back into exponentials. Okay, let's try one more sort of at this level. So this one should be really nice and easy and quick because I've done all of the hard work for you here. And then we're going to jump into something which is going to be like one level up from here. So this one is quite nice because the bases are already the same. So now we just have to worry about the exponents. Just be careful with what. Yep.
Minus 2 over 5, man.
Is it positive 2 over 5 or is it negative 2 over 5?
Negative.
Yeah, nice, 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 nice. Okay, let's chat. So our bases are the same. So I'm just going to rewrite this over here. So my bases are already both 7, which is awesome. And once our bases are the same, then our exponents are the same. So our bases are the same, which means our exponents are the same. And so 2x plus 2 is equal to negative 3x. Okay, I want to get my x's on one side and my numbers on the other side. So I'm going to move that 3x over and that 2 over, and I'm going to get 2x plus 3x on the left and negative 2 on the right. 2 plus 3 is 5x, and that's equal to negative 2. And so we divide both sides by 5 and see that x is equal to negative 2 over 5. Who got this one right? Who's feeling a little bit better? Yay, well done. Nice job, guys. Good. Good, good, good. And now, just as this confidence is doing well, I'm going to throw you into the deep end. We're going to do a nice, tough one. Let's have a look at this next one. Nice job, guys. Okay. So let's have a look at this guy now. So I'm going to go through this one. I'm going to do this one for you. If you're feeling confident, you're welcome to do it on your side as well. But I'm going to show you how to do this one. Yes, I'll quickly go back. Just take a screenshot if you can.
Right as we were doing well, you throw me right into hell.
That's exactly what my job is. My job is to get you comfortable and then just get you right back uncomfortable again. That's my whole job.
That sounds like a fun job. I would enjoy making people suffer.
You see, exactly. That's why teachers get into teaching.
Now I need to rethink my job choices.
There you go. All right, let's have a look at this question. So I'm going to do this one for you step by step. So I'm going to show you step by step how to do this question. And then I'm going to give you one to try alone by yourself. Okay, so if I'm doing this question step by step, my first goal is I want everything to still have a prime base. Okay, so I'm actually going to write this side out exactly the same. And I'm going to figure out with my prime bases of 512. I'm just going to use my calculator and do shift fact. And you're going to be able to see that that's going to be 2 to the power of 9. Okay, cool. Now I want you to think carefully. If I gave you a question where I had x squared times x times, well, let's just leave it as x squared times x. I know that I'm going to add those exponents. Okay, so that's going to become x cubed. If I had x to the power of 4 times x to the power of 6, that's going to become x to the power of 10. And so we're kind of going to do that exact same thing over here. This is going to have a 1. And so we're going to keep our base the same. So all of these have a base of 2. And we are going to add our exponents. So 3x plus x plus 1 is equal to 2 to the power of 9. And when you have a number like this that doesn't have any exponents, I recommend you write a 1 right above it straight away, because then you know not to forget it. Okay. Now, when you get to this point, you can simplify it a little bit if you want to, but you don't have to, because these bases are already the same. And when our bases are the same, our exponents are the same. So at this point, we can now write 3x plus x plus 1 is equal to 9. We keep our variables on one side. We move our numbers to the other side. So I'm going to get 4x is equal to 8. I'm going to divide that by 4, which means I have to divide that by 4. And so my final answer is x equals 2. Okay. So just want to go through what we did here. First step is we saw that all of our bases were the same, and we got this to its prime base. Then we said our bases are the same, so we can add those exponents. And we said that 3x plus x plus 1 is equal to 9, which was what those exponents were. Okay, and then we just solved for x and we got to our final answer. So that was me kind of taking you through this step by step. You're now going to try one by yourselves. So if you'd like to take a photo of this or a screenshot, you're welcome to keep it there for you. Just try and think about your steps, and then we're going to go through our next one. Lebogang, how can I help?
Can you explain from 3x plus x plus 1?
Okay, so all I've done from here is I said because my bases were the same, because they both had a base of 2, I said that this exponent is equal to this exponent. So 3x plus x plus 1 is equal to 9. I moved this 1 over. I got 4x is equal to 8, and then I just divided by 4 so that my x was lonely and said 8 divided by 4 is 2.
Thank you, ma'am.
You're welcome. Okay. Now you try.
Sir.
Hello? I'll even make this one a little bit easier. Let me make this a little, oh, should I make it easier? Yeah, let me make it a little, okay, let me make it a little easier for you. Just because I feel bad now. Here we go. Okay, well, how about this? I will write 2. If you're really struggling, then you can try this one that I'll write on the right-hand side. Okay. Okay, if you're struggling, try the blue one. If you feel like you're doing okay, try the one on the left. Cancellations in your book are good things. That means that you're like figuring things out and changing and
Ma'am,
making
the one
mistakes.
on the right is x equals 6.
I'm not going to say whether it's right or wrong just yet, just to give people a chance to get there.
Ma'am, the one on the left is x is equals to -3, I think.
Okay, I'm
Let's
also
remember to raise up our hands before speaking.
just try and give people a chance to get to the answers, guys. Shh. Guys, if you have a question you want to answer, just put your hands up for me. Kathy, how can I help?
Ma'am?
Yes.
I was wanting to explain it.
I think I'm going to go through these ones, but if you have a question, I'm happy to answer the question.
Okay.
Okay. Thanks, Kathy. Okay, so let's have a look at the one on the left for us. When we have 9s, we have 2 different options. We could either get everything to a base of 3, or we could keep things as 9s. Both of them are totally fine options. But I'm going to show you if we had used our prime bases, what it would have looked like first. Okay, so if I went to my prime bases and I made, let me just get a smaller pen. And I made this 3 squared to the power of -2x times 3 squared to the power of 3x. And I put this into my calculator, I would see that's 3 to the power of 6. Okay, so then that's going to be 3 to the -4x times 3 to the 6x is equal to 3 to the 6. And I'm going to group those ones on my left. So I'm going to have 3 to the 4x plus 6x is equal to 3 to the 6, which means I have -4x plus 6x, which is equal to 6. So 2x is equal to 6, which means x is equal to 3. Okay, so that's if I used prime bases of 3. If I had used it with 9s, I would have gotten to the exact same place. So if I'd kept this all the same with my 9s and I had changed this to being 9 to the power of 3, I would have gotten to the same place. So I would have just, at this point over here, I would have said, I've got 9 to the power of 2x plus 3x is equal to 9 to the power of 3. Please, can you guys keep yourselves on mute unless you are asking a question and then your hand needs to be up, just because it's disruptive for the rest of the class. Okay. Yingwani, how can I help?
Sorry, now I understand. Ish.
Okay, that's okay. Lebogang? Nokobonga?
Ma'am, we're solving the one on the left, right?
Yes, yes, the one on the left.
So we haven't solved the one on the right.
We haven't solved the one on the right.
Okay, ma'am.
Okay. Okay, the one on the right, that's the one we're going to end off with today. The one on the right, we're just going to leave this at this point. So we're going to say we've got 3 to the negative 2x times 3 to the 3x is equal to 3 to the power of 6. Now here, we're going to say, well, that's going to be 3 to the negative 2x plus 3x is equal to 3 to the 6. And so negative 2x plus 3x is 6. And negative 2 plus 3 is just 1x, which means x is 6. Okay, so whichever one of these ways you did, that is great. I'm hoping that something came together at some point in this lesson. That's my hope. Let me deal with these two questions. Lebogang?
Ma'am, can you explain step by step? You're too much fast.
I'm sorry. I know I'm going a little bit faster than normal. It's just because we've run out of time in our lesson time. But from which place are you getting confused, and on which question?
From 3 to the power of negative 4x multiplied by 3 to the power of 6x.
The step over here. Okay.
Yes.
So if we're looking at that step over there, all we're doing is we multiplied this 2 and this negative 4, and we got the negative 4x. We multiplied this 2 and the 3x, and we got the 6x, and then we had the 6 on the other side. And then when we have things that have the same base, we're allowed to add those exponents. So we need negative 4x plus 6x as our exponents on the left, and this exponent just stayed as 6 on the right. And then when our bases are the same, so we have 3 at the bottom here and 3 at the bottom here, we're allowed to say that our exponents are equal. And then we just solve for x. Okay, Mulanga, how can I help?
Ma'am, I just wanted to understand on the left-hand side equation. So, ma'am, you say your answer is 3 to the power 6. I just wanted to know, why isn't it negative 6? Because the exponents have different signs.
Okay, so it would only be a 3 to the negative 6 if this was written as 1 over 729. Then that would be 1 over 3 to the power of 6, which would be 3 to the negative 6. But because it's just a whole number, it's just going to have a positive exponent.
Okay, ma'am.
Okay. Guys, that has brought us to the end of our lesson today. But the good news is that we have Thursday, and we're going to carry on with some exponents on Thursday. And then next week, we're going to sort of to fill in places where there was a little bit of confusion during the course. So we're going to do a little bit of everything next week, Tuesday, and next week, Thursday. So don't panic. We're going to carry on with this on Thursday. Stay nice and calm. We'll pick up from where we left off today on Thursday. If you don't have a question, I hope you have a lovely evening and you can leave, and I'm going to answer these questions of the people who are still here. Yeah.
Ma'am, so we're not closing.
No, we still have lessons next week. So we have lessons next week, and then the week after that, there's a holiday lesson, which are not like lessons. They're sort of more problem solving and fun lessons. And then we start again on the 4th, I think.
Okay.
Okay. All right. Who is my next question?
Bye, ma'am.
Bye, guys.
So Vela, we have classes on holiday.
Well, I mean, it's only like 2 hours in your week.
My holiday. Okay, bye, ma'am.
Bye.
Bye,
Kathy,
ma'am. Bye.
how can I help?
Ma'am, I just wanna ask.
Yeah,
Ma'am?
ask away. Yeah, I'm here.
Will you teach us about midpoint theorem?
Will I teach you about? Sorry.
Midpoint theorem.
A midpoint theorem, only way later in the year.
Oh.
Yeah, because we'll do that when we do geometry, which will be quite a long time away.
Yeah, but we did written it at school.
Yes, so some schools do things in a different order, but we follow the way that the normal setup of the term schedule is. So schools that are following like the structured setup, that's what we follow.
Oh, thank you, ma'am.
You're welcome. Bye, everyone. Those of you who say goodbye.
Bye,
No
ma'am.
longer.